The one thing I'm going to tell you guys tomorrow when you guys go take, or the following days when you guys take your tests, is one, get there with your mindset on just going through what you guys already know. Okay? It's not rocket science. It's only applying what you already know. Does that make sense? So let's take a look. If you get any question that references testing for voltage or volts, what kind of tool are you using? A voltmeter. Do not, I know our mindset is DVOM, digital volt ohm meter, or MMM, multimeter, right? But the thing is it goes back to the basics. When you go take your test, if it says anything about volts testing, you're using a voltmeter. If they're talking about testing for amperage, what kind of meter are you using? An ammeter. If you're talking about testing for resistance, what kind of meter are you using? An ohm meter, right? Just with that alone, that's going to save you guys a shitload of wrong answers, right? Now, when we talk about voltage, what are we talking about when we're talking specifically about voltage? Is it resistance, flow, or pressure? Pressure. Voltage is pressure, right? So that's the pressure we need in order to push amps through a circuit. Is that true? All right. What about amps? What is amps? By the way, this is all in your guys' book, in your A6 book, your electrical. Right? This is all, everything that's in your electrical book. I just picked out the stuff that I saw on the test. Right? Amps. What are we talking about? Pressure, flow, or resistance? Flow. So anytime they're talking to you about amperage, they're talking about work being performed or the flow of current. Right? So if they show you an reading, an amperage reading, that's indication of flow, right? You got that much electron flow through that circuit, and that's what your meter is measuring, right? When we did the relative compression test yesterday, we were getting an amperage reading, right? We didn't really look at the number, but we were looking at the graph, right? So that would have been an amperage reading. If you're doing a parasitic draw test, what are you using to measure parasitic draw? Amps, right? That's the flow of current, okay? It's not voltage flowing, you're flowing current. Voltage is the method that we're using to push the current through the circuit. You guys remember that? Okay? And then lastly would be ohms, all right? Resistance, anything that impedes or slows the flow of electrons. Traffic, 91 freeway. You guys remember that conversation? Speeding down the side lane, right? The shoulder to get around traffic. Okay? Anytime that we have too much traffic, we slow the flow of vehicles, right? In an electrical circuit, if I have too much resistance, what happens to the flow? Does it go up or down? Down. So anytime I have an increase in resistance, my amperage drops. Amperage follows voltage, so if I have a drop in amperage, what happens to my voltage? Drops. Why do we do voltage drop tests? Because if we have added resistance, what's going to happen to my voltage? Right? It's going to change. It's going to reflect that. Okay. When we're talking about electrical circuits, what are the common things you would find on an electrical circuit? Name them. What do you need as a primary source of power for a circuit? Battery. From the battery, what else do we need? Switch. What about fuse? Okay, circuit protection, and then we have what? One load. Is this a series or a parallel circuit? Series, right? How many of you guys think that when you go take this test, they're going to give you guys circuits like we had to answer here in class? You're not getting one of those, okay? So, see, I told you guys were stressing for no reason, right? They're not going to give you any of those math equations, okay? Because that's more of learning theory, not practice, okay? Remember, the ASCs are based off of experience and practice. In the shop, yeah, we use Ohm's law, but we don't use it consistently. Does that make sense? So the diags that you guys are going to be doing on paper is not going to include most of this. You're going to see a shitload of voltage drop, but not ohms. Okay? So on this one here, if this was a 4 ohm light bulb, how many amps are you going to be drawing for this entire circuit? Even though you guys don't have any questions on this, I want to refresh you on this. This is 4 ohms. 3, right? Side in the back. Why is it 3? You guys remember the equation? E equals I times R. Voltage equals amperage times resistance. So if I know the resistance and I know the voltage, 12 volts, and if I divide them together, what's going to be my amperage? 3 amps. Okay? This is a series circuit. Is amperage the same anywhere in this circuit? Is that true? Awesome. I thought you guys said you had problems with electrical. You guys just don't click, huh? So current flows through the fuse into the circuit wire to the lamp, where the resistance of the lamp filament causes it to heat up, glow, and producing light. Does that mean we had a complete circuit if that light bulb came on?
Yes.
Looking at this diagram, what if this is a window motor? If I have a complete circuit, will that motor go up or down depending on the polarity? True or false? Okay. What is the difference between AC voltage and DC voltage? One goes above and below 0, which is what? AC. What rides above 0? DC. All right, good job. For shits and giggles, what is the name of this waveform? Starts with an S. Sine wave. All right. Very cool. So we're talking about AC. Okay. When we're talking about AC current or AC voltage, remember that it's going to have amplitude. When we're talking about amplitude, or you see the term amplitude, what are they referring to, or what are we referring to? Talking about current and voltage, right? But amplitude is a measurement. Are we measuring vertical or time? If I tell you guys, check the oxygen sensor amplitude, what am I referring to? Are we doing time-based measurement or voltage-based measurement? Voltage. Okay. On the oxygen sensor, amplitude is the measurement of voltage. So that is from 100 millivolts up to 800 millivolts, right? The time measurement would be frequency. Okay. Remember that? Remember I told you an oxygen sensor has an amplitude of 1/10 to 8/10 of a volt with a frequency of about 2 to 5 hertz. You guys remember that one? Okay. So that means that it's going to go from 1 to 800 millivolts, and that signal is going to repeat roughly 2 to 5 times within 1 second. Okay. That would be a 2 to 5 hertz signal, right, of an oxygen sensor. All right. When you're talking about a wiring diagram, where are you going to locate the powers on any automotive electrical wiring diagram? Top, middle, or bottom? Top. Okay. What's going to be in the middle? Loads, or your consumption, right? And what about at the bottom? Grounds. This type of corrosion, is that going to cause any type of problem? What kind of problem is that going to create? Resistance. How can I verify resistance keeping the circuit intact? Voltage drop. That's a ground circuit. What's the maximum allowable voltage drop on a ground? 200 millivolts, or 0.2. Okay? You're going to see it both ways. So if you see 0.2 V, that's 200 millivolts, right? Or if you see 0.200 MV, that's 200 millivolts. Okay? So you're going to see it both different ways, both ways. Both ways, right? So don't freak out when you see that. Just look for that decimal point. When we're talking about continuity, what is the continuity and what is the measurement of continuity? We have the meter in what? Ohms. Is a circuit isolated or intact? Isolated. That's important. Remember those two. Anytime they're referring about continuity, they're talking about what? Isolating the circuit and then using your ohm meter to check for resistance. Okay? Why is that not a good test? Because it's not in its natural state, right? I isolated the circuit. The circuit's not active, so I'm testing it pretty much asleep, right? Okay, it's like testing my athletic abilities while I'm napping. Okay, it's not going to work out very well. Does that make sense? Okay, when we're talking about an open circuit, what is that indicating to you? I'll give you an example. You have a cut wire on the ground path after the last load on a series circuit. Is that light going to turn on? Why not? Because I'm open and I'm missing a path back to positive or negative? Yeah. Ground, negative. Okay? So an open means we have what? A break or a cut somewhere, right? You guys, any of you guys ever seen Speed, the movie? Okay. What was open? The bridge, right? Okay. So they shot a couple thousand volts across that fucker because they got it across, right? So in our case, if you have an open circuit, you're gonna fall right off the bridge. Does that make sense? Okay. Think about it that way. Remember I told you guys associate it? This way when a question comes up about an open circuit, what's the first thing that's going to come to your mind? Speed, right? And the bus jumping over the gap. Okay? Open circuit. That's how I remember this stuff. You're going to see stuff like this. Okay? When you see a diagram, don't freak out. What are the first things you need to identify on your diagram during this test? Find the important stuff. Where's my power? Battery. How many grounds do I have? Two. Would you guys agree that those two grounds are shared more than likely across the biggest ground on the car, which is what? The car. The car. Okay. So now that we've identified power and ground, how many loads do you have on this particular circuit? One. Do we know any values for any of these particular components? We don't know any values, right? There's no voltage here. They're not telling you any resistance here, so we don't know any information here. Is that true? Now, let's pay attention and let's look at our meter. Where's our meter set to? Ohms. Okay? So what kind of test are they doing? Resistance. If I'm doing a resistance test, is it true that I need to have the circuit isolated? Can you verify that the circuit's isolated? Yes. How? The switch. What's wrong with the switch? It's open. Okay, so we have an open circuit here, so we know for sure this is off. So I can do a resistance test. Agreed? So now that I have it on the last leg of the circuit to ground in series, what am I measuring? 5 milliohms, right? Is that anything for me to worry about? No. It's just showing that I have good continuity. That last leg of the circuit is intact, right? Now, if they show you this one, what's the difference here? We got an OL on the meter. Oh, Lord, right? I mean, we got a problem. Okay? What happened there? Got a lot of resistance. Right, we got too much resistance, or we got an open circuit. Is that agreed? All right. So that means that we're missing a chunk off our overpass, and the bus can't get across. Right? Railroad tracks. A section of the railroad tracks is missing, so I can't get from point A to point B. I got an open. Right? So would you guys agree that I got an open circuit there? All right. So you guys see how you want to find your major key points? Put the pieces together and then be able to answer it, right? Here's the one thing I'm also going to tell you. Before you start making your judgment on what is wrong with the car, look at your 4 possibilities. Why? It can only be one of those 4 possibilities that's causing that problem. Okay? When I figured that out, it changed my whole testing strategy with ASE. Okay? Why? Because I would do these tests and I would come up with an answer that wasn't there. And then I would say, oh, those SMEs that wrote this ASE exam are idiots. No, I'm the idiot because I came up with an answer that's not even possible to them. Does that make sense? It might be possible in real life, but that's not one of the possibilities listed on the exam. Okay, so once you guys see that, see what your 4 answers are, then go to the diagram and see how can I make these 4 answers fit. Okay, like Josh was saying, you're going to see a lot of crazy stuff. You'll see a diagram, and then they're going to be pointing at 3 answers that are not part of the circuit that's wrong or bad. And then you only have 1 answer on the circuit that's bad. So obviously, what's going to be your answer? Circuit that's bad. Okay, so this is what I'm telling you guys. Stop overthinking it. Don't stress out. This is one of the easier tests that you guys are going to be able to take with ASE. All right? We got some more diagrams. What is this right here on the left-hand side? We got 2 sets of windings on this. What is it? It has a primary and secondary side. What is it? We used them yesterday. It's a coil, right? So the primary side is going to have a current ramp, right, which you guys have seen on the scope. You're not going to see any of that because you're not diagnosing drivability concerns in A6. You'll see it in A8. So when you guys do your ASE A8, it's going to be a whole different ballgame. Okay, for the A6, they're going to ask you something crazy. You have high current draw and you're blowing a fuse for an ignition coil. What can be the problem? If I'm blowing a fuse, that means amperage went up. If amperage went up, what went down? Resistance. So if I eliminated resistance, that means I can go 120 miles an hour down to 91. Okay? So if I have a short circuit and I'm blowing the fuse for my ignition coil, what is your obvious answer? Short circuit. What circuit? Primary or secondary? Primary. Okay? You guys see where we're getting at with this? All right. This one. They give you a question that says that the brake lamp is always on. All right? With this brake light on, they're going to have a voltmeter connected here to ground, and let's say they have one here to here. Okay? Then they're going to give you some measurements for those particular meters, and then you got to make a call to see which one of those meters is measuring whatever they're asking in the question. So let's write them out. If I got a voltmeter that's sitting right here, and let's say this is reading 12 volts, then we'll put another meter that's here, and we'll say this is 0 volts. Back to ground. And we'll put a voltmeter here that's showing 0 volts, and that's going back to ground. If they're telling you that this fuse is blown out, is it possible to see 12 volts in front of the brake lamp?
No.
No, right? So can we eliminate that? Okay, this is what I'm referring to. When you see the question, see how it applies into the diagram or whatever you're looking at. Your answers, I mean. Okay? So if I see an answer that says I have 12 volts here, but they're telling me the fuse is blown, that's not possible. Because a computer is not going to be sending voltage to a light, right? They usually send a ground circuit. Because if I send voltage, I can overload the driver and burn the computer out, right? So this is why we're going to be controlling the ground circuit, not the power circuit. Okay? Any questions on that one? All right. Okay. All right. If we're doing a voltage drop on the backside on the ground circuit after the last load, how many volts? Scratch that. How many volts should you see after the last load on the circuit? And the circuit's on. So notice how I have a light bulb that's on right here, right? Let's say for conversation's sake, this battery has 12 volts. When I turn on that light bulb, how many volts am I going to have after the last load? 0. Okay? You just answered a shitload of questions on that exam. After the last load, how many volts did you see? 0. If I see source voltage after the last load, what is that telling me? Two things. I have an open ground circuit, or I got a damaged component. Okay? If I have source voltage after the load, more than likely, about 99% of the time, you have a missing ground or it's off. If this was on, I'm going to use up all source voltage here and I'm going to have 0 left over, right? Okay? So again, it goes back to reading what they're asking you. So to find high resistance, we always recommend doing a VD. Voltage drop test I'm doing here is on the starter circuit on the positive side. What's the maximum allowable voltage drop from the battery positive to the starter pole? How many? 200. You guys remember that one? It's 300 for an alternator. Okay, remember? That's a starter. It spins. Can't we just call it a damn alternator, right? Okay. So your starter is 200 millivolts, positive and ground. All right. 300 millivolts on the starter is across the solenoid. Remember that one? Okay. So if you're across the solenoid, it's 300 millivolts. Power from the battery to the starter is how many? 200. Ground circuit to the starter housing, 200. Okay? And here it is again. Voltage drop on the ground circuit is 200 millivolts. Voltage drop from the battery positive to the starter, I put a 3, but it's 2. That's my bad. Battery to the alternator is 300. Battery post to terminal is 200. And across the starter solenoid, I mix these up. That's a 3. What is the key to do a voltage drop test? Circuit active or circuit not active? In a voltage drop test? Active. Okay? You got to remember that. A voltage drop test I'm doing with the circuit active or loaded. If we're doing it on the starter, you're cranking it. Don't do it with the car not cranking because you're really not doing anything. If you're testing the circuit from the alternator to the battery, you're doing it with the car running. If you're doing a full ground integrity from the engine, from the battery negative to the car or the chassis, that's with the vehicle running, and it should be 200 millivolts or less. Okay? Right?
Solenoid is 300.
Across the solenoid is 300 millivolts.
And the starter is 200.
Starter's 200. I mix these up. This is 3. That's 2. Did you record it?
What? Recorded.
That's 2, and this is 3. All right. You guys ready for some Ohm's law? Silence. That's scary. How many of you guys remember what Ohm's law states? It takes 1 volt to push 1 amp through 1 ohm of resistance. You guys remember that one? Okay. It takes 1 volt, because remember, voltage is pressure. So it takes 1 volt of pressure to push 1 amp through 1 ohm of resistance. We got two diagrams here. We got a load device, and then we have excessive voltage drop on an improperly functioning circuit. We see descriptions here, but let's go ahead and take a look at the circuits and see what's up. Looking at this particular circuit on the left-hand side, what are you doing with your meter? It's set to volts DC. So our voltmeter is set to volts DC. So we're checking voltage of some sort or a voltage drop, one of the two. Right? So now let's go and take a look. How is my voltmeter connected? Across the load? Okay, so in theory, what test am I running? Voltage drop. If I'm seeing 12.48 volts across the load, how many volts does this battery have? 12.4. Right? Why? How do I know that? How many loads are consuming electricity on this circuit? One. So how many volts is that load going to use? All available voltage. So if I'm getting a 12.4 voltage drop across it, how many volts does this battery have? 12.4. Okay? On this one, I have my voltmeter connected from the positive terminal of the battery and on the output of a switch. Here, my voltmeter is still volts DC, and I'm getting a negative 1.2 volt voltage drop. Is a negative a problem?
No.
What does that mean?
Just means the cables are switched.
Leads are backwards. Okay? Beautiful thing about using a voltmeter. Now, if I have 1.2 volt voltage drop from the post going through a fuse and then going to a switch, is that a problem? Okay? What kind of problem is that going to create for that load?
Dim load.
Dim load probably won't even work or turn on, right? If I'm losing 1.2 volts across this circuit, I'm going to do two things. One, I'm going to do a voltage drop across the switch. What's the maximum allowable voltage drop across the switch? 200 millivolts. If I get 200 millivolts on that switch, is that a good switch? Okay, then I'm going to go, what's the next step? Fuse. If I go across the fuse and the fuse has way more voltage drop, let's say the fuse is showing 1.0, is that your problem? Okay, and this is what you're going to be seeing on the test. They'll give you a diagram with multiple meters the way it's set up here. So let's look. The next meter is connected across the load, volts DC, and it's showing 11.3 volts. Is that a problem?
Yeah.
If I add those 11.3 to the 1.2, what does that give me?
12.4.
12.5, right? And what did I have before? 12.4. So does that math add up? Yeah. So that 1 volt that I'm losing it somewhere in this area here. So if any of my questions lead me to a voltmeter or a component that's in this area, any of my answers, that's going to be the one you want to focus on, right? Because they're telling you that you might have a bad switch. Is that a valid answer? Yeah. What do they tell you? You have a bad connection at the fuse. Is that a valid answer? Yeah. Anything that's within that circuit. What if they tell you that this ground has high resistance? Can that cause that problem?
No.
No. That has nothing to do with my voltage drop. Where's my voltage drop?
In that area.
Before the load, not after. Okay? You see where I'm getting at? Right? So you got to look at that information so this way you know where am I looking for this particular problem. Right? It's not like the cars that come into the shop where we have no clues. Right? You're taking a test, you have 4 possible answers. So you got 4 clues. Now, use the puzzle pieces to put those 4 clues together. Okay? So Ohm's law is a relationship between volts, ohms, and amps. Is that true?
Yes.
Okay? So you guys remember, V equals A times R. I showed it to you guys both ways. E equals I times R, or V equals A times R. R is resistance, V is voltage, and A is amps. We need 2 of the 3 to determine the one we don't know, right? So if you were to get any type of question that gives you voltage and amperage, what are you solving for? Resistance. Okay, and if you get one that gives you voltage and resistance, what are you solving for? Amperage. And if you get resistance and amperage, what are you solving for? Voltage. Okay? You guys remember this? All right, we did this one already, right? We got a 4 ohm resistor with 12 volts. What's my amperage draw? 3 amps. That's a series circuit. Is it true that amperage is the same anywhere throughout that circuit? Yeah. Okay, you guys remember wattage? What's the measurement of wattage? Wattage is the measurement of amps times volts. Okay, so wattage is power. Anytime somebody tells you how much power is that unit pulling, they're referring to the wattage. The way you calculate wattage is multiply amps times voltage. If you got a 12 volt circuit with 4 amps, how many watts are you pulling? So we want to do the math. 12 volt circuit and 4 amps.
48.
48. You're drawing 4. That's a 48 watt unit. Okay, has anybody ever bought a generator? What is your generator rated at? Wattage. Okay. So whenever you guys go buy a generator, it's rated by wattage, right? It's going to give you 120 volts, but depending on the amount of output wattage, that's how many amps that's going to be able to sustain. And so if you bought a small generator to run a welder, it's probably not going to work very well. Does that make sense? Okay. You go buy an $80 generator that has an 80 watt output, and you're trying to run something that's drawing a good 40, 50 amps, it's not going to work. Okay. You guys remember these? All right, so what kind of circuit do we have here?
Series parallel.
Is this
Series.
is series, right?
Yeah.
We have 3 meters that are in series. So on this circuit, we have 12 volts at the battery, and we have 2 loads across it. First load has 9 ohms of resistance. If I want to know what the voltage drop here is going to be, how do I figure that out? You guys remember this? So I'm trying to solve for voltage. What 2 things do I need to solve for voltage? Amps and resistance, right? So in order for me to solve for amps, I need to do total resistance into voltage, right? So what's my total resistance of the circuit? 12. How many volts is it? 12. 12 goes into 12? Once. So the total amperage for the circuit is 1 amp. Because I know it's 1 amp, 1 times 3 is what? 3. So I got a 3 volt voltage drop across that load. This one has 9 ohms of resistance. What's 9 times 1? How many volts voltage drop across? How many volts total do you have? What's 9 plus 3? Did we do the math correctly? Awesome. Okay. Teachers did a great job. We learned how to do math. Okay. I would have needed a calculator to use my toes and shit for this one. This is kind of the same thing here, right? And we just reversed the resistance. So if you guys get any type of question, which I didn't see any, okay, that has this kind of stuff, are you guys going to be able to solve for it? Yeah. Here's what I'm going to tell you. When you get there, they're going to give you a blue sheet of paper. When you open it up, it has front, inside, inside, outside. So it's technically 4 pages of paper. And you get a pen. You used to get 2 pencils, but now you get a pen. As soon as you get to your cubicle, because they're going to seat you in a cubicle, first thing you're going to do is you're going to put your keys, because there's a pad that says key and ID. So you put your keys for your locker and then your ID. The next thing you're going to do is you're going to write down V equals A times R on your scratch paper. Okay? Then write down as many of the voltage drops that you can remember. Grounds, 2/10. Alternator, 3/10. Okay? This way, once you get digging into the test and you forget some of this stuff, you have reference material there. Right? It's not illegal to jot down your own thoughts. So write them down. Okay? They're going to look at the scratch paper and then they're going to shred everything. Right? So if you want to do that, go for it. E equals I times R. Or V V equals A times R. Okay, if you want to go that route. Just kind of help yourself, so this way you guys are there, fresh, ready, and I want to be writing a shitload of checks in the next couple of days. When we're talking about a series circuit, how many paths of current flow do we have? One. Okay? So a series circuit is going to have one path of current flow. Ha! I tricked you guys. We're going to do some math real quick. I got a 12-volt circuit with 3 amps. What's my resistance? I got a 12-volt circuit with 3 ohms. That's so difficult, right? All right, now I'm getting harder here with you guys. So we got 6 ohms of resistance and 2 amps. What's my total voltage?
12.
Everybody agree with 12? And I have 3 amps and 12 volts. What's my resistance?
4.
So what's my missing resistance?
2.
It's 1, right? If I got 3 ohms and I need to be at 4, how many am I missing? 1. Okay? Parallel circuits. Dun, dun, dun. How many paths of current flow do you have in a parallel circuit? Many, right? Multiple. More than one. Okay, so you're going to have branches coming off. Okay? You guys remember these? How do we solve for these?
You add your resistance.
So these are the same, so they can divide, right? That means we have total of how many? We have 2 4-ohm resistors. They divide 4 into 2, right? And that gives you what? 2. So my total resistance would be 2 into 12 volts. How many amps? Okay? I know this is not going to be on the test, but I want you guys to be very familiar with Ohm's law. All right, we got 4 amps into 12 volts. How am I going to get that? What's going to be my total resistance? If I got, how many times does 4 go into, or 12 go into 4? 3. Okay, so that means this has to be what? What's R2's value? How can I get 6 and make it 3? I have to make it 6, right? If it's 6 and 6 with 2 of them, does that become 3? Okay. Now in this one, we have 2 12-ohm resistors and a 12-volt circuit. What's going to be my amperage draw for this circuit? We got 2 12s. Does that divide into 2, making it 6? Right? So I have 6 ohms of resistance into 12 volts. What's my amperage draw? 2 amps. And the last one has 2 4-ohm resistors. Can we divide those 2 and to make it 2? And then we have 2 2-ohm resistors. Can I divide those and make it 1? Okay, so my total resistance is 1 into 12 volts. What's my amperage? 12, right? Okay. All right. You guys remember Kirchhoff's law? What does it mean? What does it state? His law tells us that in any closed loop circuit, the total voltage drop around the loop is equal to the sum of all the voltage drops within the same circuit. Is that true? Are all my voltage drops going to add up to source voltage? Yeah, bless you. Okay. Why? Because we start with a certain amount. It all has to add up to whatever we started with, right? Okay, so if I start with 12, all my voltage drops across the circuit at the end have to equal 12, right? If they don't, is there a problem? Yes. That means I got a voltage drop somewhere. Voltage drop is equivalent to what? Starts with an R. Resistance. Okay? You guys remember looking at this one? So let's look at it real quick. Here's our main battery source. And point A is our post and terminal. From there, we leave the post and terminal through our fuse protection, and we end up at our light or our load. So from A to B, voltage drop is 0.025 volts DC. Okay, that's 25 millivolts. Is that acceptable? Yeah. Okay. From B to C, which is across the load, what am I seeing? 11.835 volts. Does that mean that that load is using up that available voltage? Yeah. Okay. From C to D, I have 0.025, which is 25 millivolts. Is that acceptable? Yeah. Okay. Across D and E, I have a voltage drop of 0.06, 60 millivolts. Is that acceptable? Yeah. From D to F, I have a voltage drop, from E to F, I have a voltage drop of 30 millivolts. Is that acceptable? And then from F to G, or from G to H, they're giving you 25 millivolts. Is that acceptable? Yeah. If you add them all up, what's your voltage? 12 volts. Now, if they give you a question like this, right, and they tell you that from F to E, you're getting 30 millivolts, that's okay. But then they're telling you from E to D, you're getting 2.0 volts drop. Is that a problem?
Yeah.
What kind of problem is that going to cause for your headlight?
Probably not going to work.
It's probably not going to work with 2 volts. You guys remember when we added 1 ohm of resistance, how dim did that light get? We added, what, 4 ohms and it wasn't even on anymore? Or 10. It was at 10 and it was barely coming on. You guys remember that? Okay. All right. What voltage am I testing here with my meter? AC or DC? Okay. And my meter, am I checking for voltage, voltage drop, or amperage?
Voltage.
Voltage. Am I checking for potential or am I checking for flow?
Potential.
How do I know? How do you guys know it's potential?
Checking the battery across the positive and negative to see what pressure it's creating.
Love it. I'm across the positive and negative side of the battery. I'm checking the potential difference from positive to negative, right? And my potential difference is 12.6 volts. Is that a fully charged battery?
Yes.
Okay, so you guys agree the state of charge of that battery is 100%. Okay. Ooh. What kind of circuit is this?
Parallel.
This would be a parallel circuit, and this is a multifunction switch or a headlight switch of some sort, okay? Looking at this diagram, what does it mean when you see a dashed line connecting 2 pins together?
Both move together.
They move in unison. Is that important for you guys? Yes, because you are going to get some diagrams like this. So if you see a dashed line that connects 2 points or 2 contacts, that means they work in unison. So if you push that switch or that contact, they're both moving at the same time. Okay? The other part, if you guys notice that it has this dashed box around it, that means it's part of a bigger diagram. Okay? Just in case that pops up. The small little dash around it just means that they've kind of zoomed into that particular part of the diagram. There's more to it. Okay? Looking at this one here, this is my turn signal flasher. Is this flasher controlling power or ground to my circuit?
Power.
Power. How do you guys know that? It's at the top, right? So that's going to send power down. So this is normal. Contacts are here. So the circuit's open. Once I go this way, okay, I'm going to go here, and then that's going to send power down to my turn signal, and that's going off to another wiring diagram, okay? So these right here are all interconnected. If I get a movement this way, then that means this one, and this one are going this way along with this and this. Okay, so all 4 contacts are switching. How do I know that? Because they all have an individual dashed line together. You guys see that? Okay, so if you see that on the diagram on a question, what is that telling you? They're all moving together. Okay? Now, you guys remember this one? So let's look at this. We got 1, 2, 3. What are those called? Relays. Do you guys remember the 4 pins of a 4-pin relay?
86.
Let's start with 85. Is that power or ground?
That is power.
Sure?
30 is power.
30 is going to have unswitched or fused power, right? We call that one out. We'll start with that. 85 is your ground control. Okay? and 86 is going to be your power. That's the coil. So that would mean, looking at this, what provides my ground? What pin is this? This one right here. That's 85. I have a ground, comes up. So this is pin 85, right? What pin is this?
87.
86, right? This is a coil side, so this is 86. Once I have power here and ground here, I have a magnetic field here that's going to close this relay. Is that true? This is pin 30. Do you guys agree?
Yeah.
So from pin 30, once I magnetize this and close, I'm going to have power flowing through the relay. And what pin is this? What's your output power on a relay? It's an 8. 87. Okay? So 85 is ground. 86 is power. 85 and 86 control the coil. Pin 30 is power in. And pin 87 is power out. Okay? So if they give you a question and they're telling you that this relay has a voltmeter connected across it, and when it's across here and here, pin 85 and 86, you're seeing 12 volts when it's commanded on. What's wrong here? So I have a voltmeter from here to here. This relay is commanded on, and I'm seeing 12 volts here. What is that telling me? Relay didn't come on. Right? Do you guys agree with that? If I have a voltmeter from here to here, and I'm seeing 12 volts, okay, what is that telling you? Relay shorted? You guys agree? Yes? No? Maybe so? No? I see some no's, I see some yeses. Take your time, look at it. If you guys have your A6 book, this picture's in there. You guys can go back and take a look at it. If I have 12 volts here and a ground circuit here, right, with this active, how many volts are going through it? 12 or none?
Wait, so you have 12 volts at the top.
I have 12 volts up here and a ground circuit here.
And a ground circuit there.
How many volts should I expect to see across the coil? Let's go back to this. Should be this one. If I have power and ground to that load, how many volts are you seeing? So what are you supposed to see if I have a voltmeter connected across my relay and the relay's turned on? So if I have a voltmeter here and I turn this on because I have power and ground, how many volts am I going to see?
It shouldn't see none. It should be up all its voltage.
But we're across the load, right? So how many volts am I going to see? 12. Okay. So if the question states that you've turned this on, but it's not sending power out, and you have your voltmeter across it and you see 12 volts, that means that the relay turned on, right? It just didn't close. So is that a faulty relay? Yeah. Okay. Got you guys sweating, huh? Right? It was just the way I worded it. I confused the shit out of you guys on purpose. You guys remember that?
Yes.
Okay. What is this right here? What does that mean?
There's no current.
That means allowing current flow in one direction but not the other, right? If this is a ground circuit, whenever ground travels, I'm not going to allow back feed back into the computer, right? Remember, computers hate amperage, so if I'm going to shoot that back, that's voltage spike, I can fry the computer or shut it down. Okay. Looking at this diagram here, we have another relay. So these, looking at these, what pin is this? 86 or 85? And this one? And what controls the ground circuit to my relay, coil side? Switch. You guys agree? Okay, so when this switch closes, that's going to magnetize this relay, and that's going to close the relay and turn on my lights. Is that true? Okay. What about on this one? I have a motor, a PCM, 2 fuses, and a relay. Which one turns on my motor? Relay. What controls the relay? PCM, right? So now you know this is a computer-controlled relay. So if this relay doesn't come on, and they tell you that you're testing it, and you're seeing 12 volts on this side, and 12 volts on this side, with the meter connected to an opposite ground, so you're in parallel, what is that telling you? You don't have a ground circuit. Who controls the ground circuit? PCM. Okay? How is that different from the other one? The other one, we were in series, right? I just said we were in parallel. So that would mean that I have one test lead here, and I have a ground lead somewhere over here, right? I'm in parallel, okay? Voltage drop, we're cool with those. How are we going to measure voltage drop? How do you set up your meter? Volts DC, okay? So once you have your meter set up to volts DC, are you in series or are you in parallel when you're doing a voltage drop? Series. That means I became part of the circuit, right? Look at how we have our diagram set up here. I have V1, voltmeter number 1, connected across the battery, right? Then I have a V3 doing a voltage drop across a resistor. It has a 3 ohm resistor. What is going to be the voltage drop across that specific load? What do you need to do in order to solve for this?
Divide the 3.
Is it multiple paths or are they in series? They look in series to me because they're back to back, right? So I add these. That would be 6. 6 into 12 is 2. Total amperage is 2 amps, right? 2 amps times 3 ohms of resistance. What's my voltage drop? 6 volts, right? If I use up 6 here and I have 12, how many do I have left for this one? 6. This one's also 3 ohms of resistance, so what's my voltage drop? 6. Okay? Okay. How do we measure current? You guys saw it multiple ways, right? You guys remember when we put our meter in series and the current flowed through the meter and showed it on the screen? And then we did it another way. What was the other way? Amp clamp, okay? We were checking for what? Magnetic field, right? Okay, so anytime you're going to be doing a actual current test, make sure that you move your lead, right? You guys have your voltmeter in front of you, like this one right here. Notice how we have a COM port, and then I have volts DC, and then I have amps, and then I have milliamps here. And some meters are going to have a different port whenever you are testing voltage AC, okay? So it just depends on the meter. This one right here, since if we're doing amperage, then I need to move my red lead over to one of these two, okay? So if they show you a picture like this, this has an A on it. This is COM, and this is volts and ohms. What are they testing here? Amps, right? You guys look at the knob. Where's the knob pointing to? Amps. Amps DC. Now, if you look at this diagram, I have ammeter 1, 2, and 3. Are they in series? So what am I measuring? Amperage, the flow of current, okay? What are we testing here? Ammeter 1, ammeter 2. Are these in series?
No.
They're in series, right? Because they're part of the circuit now. Current's flowing through it, right? Current's flowing through it. So these are in series, okay? How can we use Ohm's law to diagnose circuits? if I know what the resistance value is, right, I can determine the amperage. If I check the amperage and the amperage is different than what my calculation was, based off of the voltage available, I can figure out what kind of problem I have. Is that true? If I have a drop in amperage, what happened to the circuit? Did resistance go up in the circuit or drop in the circuit? If amperage dropped, or amperage is lower than what I calculated it should be, what happened to resistance? It went up. Okay? And if I test it and my amperage is higher than what I should expect, what is that telling me? That means I dropped in resistance. Okay? Is that important for you guys when you're looking at schematics in these next couple of days? Yes. If you see that they're telling you that for some reason you have a higher amperage draw, what does that mean within the circuit? Something lost resistance, right? If there's only one load in the circuit and that's the only thing they're showing to you testing, is that the highest possibility of that being the bad component within that circuit? Yes. Okay. Now, if they're showing you some voltage drop tests and you see some resistance values that are off, that could be the issue. Okay. Again, it goes back to what are your 4 possible answers, right? Using the relationship to demonstrate to guide you through the diagnosis process. This is number 2. Just like I said, you're already knowing what to expect, right? If it doesn't match with what you have in front of you, that is a problem, right? Okay. What are we doing here? Checking fuses? Okay. So they're checking fuses with a test light. Is that acceptable? Okay. Are you supposed to use the test light on a computer-controlled circuit? Why not? I could damage the circuit, right? Because it's now in series, and that's going to increase the amperage on that circuit. Okay. When is the only time I allow you guys to use a test light in a circuit? You guys remember we talked about load substitution? So if I'm substituting the load, can I use a test light if it has the same amount of current draw as the component that's in that circuit? Yes. Okay. Okay. Whenever we have whenever we have an open circuit, that means we have a break in the electrical circuit. Is that true? Okay. So open circuit means that either we're missing a power or we're missing a ground. Can it also mean that the circuit's off? Yes. Okay. So be careful with that word. If you see open circuit, that's not always a bad thing. They could also be referring to that you have a switch that's in its open position. Okay? So this is why you're going to read the question, read your answers, and then look at whatever diagram they put in front of you. Okay? How can we locate an open circuit? We do a voltage drop test. Are there any tools that we can use to make this process a lot easier? Like a short circuit finder, right? Okay? For you guys, they're going to do voltage drops. And when you take the test, they're all going to be VD. Okay? Good there. All right. So remember rodent damage. Okay? If you are going to be testing for damaged circuits, always make sure you're using some sort of circuit protection so nothing happens, right? That's the high resistance protection device. So what's a protection device? A fuse, right? So that means we're talking about some sort of fuse. And how are fuses rated? Amperage. Okay? You got to remember that. These are some of the little basic things that might come up. A fuse is rated in amperage. This also comes up, so I slapped this in here. We're going to be talking about CAN bus in the next couple of days, but it's going to pop up. So here we are. CAN bus. How does CAN bus, or the CAN bus circuit at idles at how many volts? How many of you guys know? If you don't know, all you got to do is look at it right here. This is a CAN bus at idle is how many volts? It's 2.5 volts. Okay? So if you get any question on a CAN bus, what is the idle voltage that bus is idling at? 2.5. Okay? CAN has 2 pins, CAN high and CAN low. When the bus is not active, it's both going to be idling at 2.5 volts. Whenever the bus becomes active, it drops 1 and ups 1. CAN high goes up to 3.5, CAN low goes down to 1.5. Okay, so I'll say that again. CAN high and CAN low idle at 2.5 volts. When that bus comes alive, it goes up 1 volt and down 1 volt. Okay? If you get any type of question that shows that this is not at 2.5, is that showing a problem? Yeah. If you have this idling at 1.5, what kind of problem is that? If voltage has dropped lower, resistance, okay, what else? Possible short? Possible, right? If I see that this is 3.5 or 4.5, I've seen some Chevys go up to 12 volts, okay, when they short out on their splice packs. Is that going to be a problem? Yeah, okay. If you see anything other than 3.5, that means it's feeding voltage from somewhere, okay? You got to see how much voltage they're showing you, right? Usually the questions or something like that would come about just saying what is the bus idle and then up and down how many, okay? So CAN high goes up how many volts? CAN low goes down how many? 1. All right, wiring diagrams. When we're looking at wiring diagrams, where are my powers located on a wiring schematic automotive? At the top. Where are my loads located? And grounds? At the bottom. Okay? Remember, when you see a dot, that means it's a splice. That means those wires are interconnected. Okay, they are going to give you guys diagrams. They're not complicated. The diagrams that I've shown you guys are 1,000 times more complicated than what you guys are going to see. Okay? So again, if you see a dot with multiple lines intersecting, that's a splice. They're connected in some which way, shape, or form. Again, how do you verify it? If it has an S number right next to it, that's a splice number. Okay? So S101 is splice 101. S104 is splice 104. Okay? If you notice on these, they're not interconnected because there's no splice. Is that true? So if you see a diagram like that, don't trip. They're not connected. The wires are probably just laying on top of one another. Right? If I see something that says G104, what is that referring to?
Ground.
It's a ground. What if it says C232?
Slide.
Connector. Okay? That's important because you're going to get answers that say voltmeter W at connector C42. Okay? And if you're looking at the wrong connector, that's going to give you the wrong answer. All right? How many of you guys have issues with wire colors? It's kind of self-explanatory, right? BL blue, BLK black, okay? BRN is brown, so on and so forth. Okay, WHT is white. All right, it's kind of easy breezy when it comes to that. Wire color is usually going to be listed by the wire itself. Okay, grounds are going to be numbered with a G, just like we were saying. The circuit number is going to be listed on that particular circuit. So here we have a BCM, we have black, a ground circuit, pin 3 of this connector, circuit 1650. Okay. Connector again starts with a C, and components are usually located mid-center in that wiring schematic. So looking at this wiring diagram, do you guys agree that the powers are coming from the top to this splice, and all 4 of these lights are saying the same power? Yeah. Okay. Then each one of these is controlled via a ground. We can't see it, but obviously it's running to the bottom, so it should be one of the grounds. I can confidently say that because they're all sharing the same power. Okay? We got another one. We got a voltmeter. It's set to volts DC. Do you guys agree? Okay. This voltmeter is connected from pin ground control, which is what pin on the relay? 85. So I have a meter on pin 85 in series to the ground circuit from the horn switch. I'm seeing 12 volts. What is that telling you? That means I have the potential to use 12 volts, right? But I'm not using them yet. Okay? Once I close this, then I'm going to zero this out. Notice what happens here. We have a voltage drop from the output, which is pin 87, to ground, right? Pin 87 to ground, and what am I showing? Zero. So that means that there's no current flowing, right? Relay hasn't closed. It's open. Okay? Looking at this one, I'm doing a voltage drop across the relay. It's not active, right? Look, it's open. What about here? What kind of tests are they doing with the meter on the top? Voltage drop, resistance, or amperage? Voltage drop. They have a 270 millivolt voltage drop from the positive of the battery through the fuse, through the switch, and to the light bulb. Is that acceptable?
No.
It's a power, though. How much power can you flow through a circuit? 300, right? Okay. So it's at the peak. It's at the max, a little high, but that is acceptable. Okay, what about this one? I'm on the ground side of the light bulb, back to ground on the battery, and I'm seeing 2.6 volts. Is that a problem?
Yes.
Okay, so do you have a ground circuit issue? Or would you go with a question that has anything to do with unwanted resistance on the ground?
Yes.
Yeah, right? Okay. Well, if they give you a question or an answer that has anything to do with the power side, is that going to affect this output on this meter? No, because they're doing it on the ground circuit, so the problem is where? In the ground circuit. Okay. What are we doing here with this particular fuel injector? What meter am I using? An ohm meter, and I'm checking ohms, resistance, right? I have 11.8 ohms, and the specification calls for 11.5 to 12.4. Is that acceptable?
Yes.
Yeah. So if any of the answers were saying that fuel injector is good, would you guys agree? Okay. And what are they testing here? So it's in volts DC. I'm seeing 8.36 volts from a power feed to a ground feed. Is that a pretty big voltage drop for a headlight? That means I'm losing 8 volts from there to there. Is that bad? Okay. What should you normally see? If this is on, I should expect to see 0, right? Because I'm across it. I'm using it all up, and I shouldn't see anything on the opposite side. Okay. Here, we have a headlamp in series across a fuse. What kind of test are they doing here? No. What kind of test are they running? Even Siri wanted some action. We use it as an ice pick or to shank somebody at the shop. Test light, right? You guys remember a test light? You guys remember doing a test light, disconnecting negative on the battery and putting your test light in series, and if the light's on, what does that mean? That means you have current flow. That means you have a parasitic draw, right? You guys remember that we use an amp clamp, this one, to test for that? Okay? So what they're showing you here is they're doing a parasitic draw test. They're verifying if I'm drawing current, right? Remember, if you have a current draw, is it true that I need a small amount of resistance in order for that circuit to be complete? Yeah, right? So if I put resistance from this bulb in between that fuse, would you guys agree that if that turns on, that means that that circuit is live? Yeah. So if you guys get any type of question and some answers that you put this in series and it lights up, isn't it true that you guys have a parasitic draw? Something drawing current. Okay. What are they doing here? I'm on the ground side to ground, and I'm seeing 10.3 volts. Is that a problem?
Yeah.
That's a bad problem. Okay. Is a problem on the power side or on the ground side? So if they give you any answers that have to do with the power side, are you going to ignore those right off the bat?
Yes.
Yeah. Okay. Any questions?
Can you do it all over again?